In today's video, we'll talk about geometric sequence as applied in real life. Problem number 1. A virus population doubles every 30 minutes. It begins with a population of 30. How many viral cells will be present after 5 hours? So let us make a table of values to illustrate the problem. Let us denote the time by t and the amount of virus by a sub n. So when t is equal to 0, the initial amount is 30. So let us denote that by a sub 1. Now, after 30 minutes, magdo-double yan. So the virus becomes 60. No? Let us denote that by a sub 2. And after 1 hour, magdo-double uli yan. Magiging 120 na. Let us denote that by a sub 3. Okay. Now, from the table, you can see that this follows a geometric sequence, no, with a common ratio equal to 2. 60 divided by 30 is 2. 120 divided by 60 is 2. And therefore, to get the number of virus after 5 hours, we are actually looking for a sub n after 5 hours. But what is n? Kailangan makuha natin ang n para makuha natin yung number of virus after 5 hours. So since there are 10 30 minutes in 5 hours, meron tayong 10 30 minutes in 5 hours, that means that from a sub 2 up to a sub n, we have 10 terms, right? Now, if we add a sub 1 to 10 terms, that would have a total of 11 terms. And therefore, we are actually looking for a sub 11, which is the amount of virus after 5 hours. So, since again, this is a geometric sequence, we use the formula a sub n is equal to a sub 1 r to the n minus 1. A sub 11 is equal to a sub 1, which is equal to 30. R is equal to 2 raised to n minus 1 or 11 minus 1. So this is equal to 30 times 2 raised to 10. But 2 raised to 10 is equal to 1024. And 1024 times 30 is equal to 30,720. So the amount of virus or viral cells after 5 hours is 30,720. Problem number 2. The initial population of rabbits on the farm was 20. The population increased by 8% each week. How many rabbits were present after 10 weeks? Okay, any problem that has a fixed percentage increase forms a geometric sequence. In other words, kapag ang population or any number ay nag-i-increase by a certain percent, asahan nyo that is a geometric sequence problem. Now, in this case, hindi na natin ililista yung mga terms, no? Why? Because we have a way of solving for R even without listing the terms. Paano? Well, to solve for R, all you have to do is to add the rate of increase to 100%. So R is equal to 100% plus 8% or 108%. Now, changing this to decimal form, that is equal to 1.08. Just move the decimal point twice to the left. Okay? Now, how do we determine the number of rabbits present after 10 weeks? Well, we are actually solving for a sub n after 10 weeks, right? But the problem is, what is n? Ilang terms ba ito? Kailangan malaman natin kung ilang terms yan para ma-determine natin kung ilan ang rabbits after 10 weeks, right? So to determine n, we know that a sub 1 is reserved for the initial amount, which is 20. Now, the amount after a week will fall under the second term na, right? Nandito yung first week natin. And therefore, if we have 10 weeks, pang ilang term ito magpo-fall, no? So from a sub 2 up to 10 weeks, we have 10 terms, right? And therefore, n is equal to the first term, which is a sub 1 plus 10, that would give you 11 terms, right? So, since n is equal to 11, we are actually looking for a sub 11. So, using the n-term formula, we have a sub 1 r to the n minus 1. So, a sub 11 is, a sub 1 is equal to 20, r is equal to 1.08 raised to 11 minus 1. So, this is equal to 20 times 1.08 raised to 10. Now, using your calculator, 20 times 1.08 raised to 10 is equal to 43.18. But since we are talking about the number of rabbits, kailangan walang decimal, no? And therefore, after 10 weeks, we have 43 rabbits. Okay? Problem number 3. A tool and die company buys a machine for $175,000 and it depreciates at a rate of 30% per year. Find the depreciated value of the machine after 5 years. So just like in example number 2, this problem tells about a fixed percentage change in value and therefore forms a geometric sequence. Only this time, the value depreciates, no? Sa number 2, nag-appreciate yung population. And as I said in the previous example, if the value depreciates, then we can solve for R by deducting, no, the rate from 100% instead of adding it. So, to solve for R without listing the terms, R is equal to 100% minus 30% or 70%. So, in decimal form, this is equal to 0.70. Now, how do we find the depreciated value of the machine after 5 years? Well, to find the depreciated value after 5 years, we solve for a sub n after 5 years. But what is n? No, after 5 years. Again, just like in example number 2, we add the number of years to the first term, which is the initial amount of the machine. And therefore, n is equal to 5 plus 1 or 6, right? So since n is equal to 6, we are actually solving for a sub 6. And a sub 6 is equal to a sub 1 r to the n minus 1. But a sub 1 is equal to 175,000. And r is equal to 0.70 raised to 6 minus 1. So that is equal to 175,000, 0.70 raised to 5. But 0.70 raised to 5 is equal to 0.16807. And using your calculator, 175,000 times 0.16807 is equal to 29,412.25. So that's the value of the machine after 5 years. Problem number 4. A ball is dropped from a height of 6 feet and begins bouncing. The height of each bounce is 3/4 the height of the previous bounce. Find the total vertical distance the ball travels before coming to rest. Okay, the phrase before coming to rest indicates that this is an infinite geometric series problem. And the formula to consider is S infinity is equal to A sub 1 over 1 minus R. Now, since the initial height of the ball is 6 feet, this means that A sub 1 is equal to 6. And since the height of each bounce is 3/4 the height of the previous bounce, it clearly shows that R is equal to 3/4. So substituting these values, we have 6 over 1 minus 3/4. But 1 minus 3/4 is equal to 1/4. And 6 over 1/4 is equal to 6 times the reciprocal of 1/4, which is 4 over 1 or 24 feet. So the total vertical distance the ball travels is 24 feet.